Myself, Edwin Das. In this lecture, we are going to see how to convert a MATLAB code to Verilog code, Verilog or VHDL using MATLAB HDL Coder. MATLAB HDL Coder. Okay, for this example, we are considering one example of clock divider circuit. Clock divider circuit for clock divider by 5, right? So as we know, a clock divider by circuit 5 circuit will divide the clock by 5, clock frequency by 5. Um, so let's start the MATLAB program. So the MATLAB program first begin with function. So the clock divider circuit input, there will be only clock input. So no external data input will be there. So therefore we must frame like this. What about the output argument? There will be one output argument. So there is clock out. The divided clock output must come through clock out. One I am declaring one variable clock out. So what about the function name? I am giving it as the circuit name is clock divider, right? So I am using clock divider. So what will be the input argument? There will be no input argument. So the function must begin like this and it must end with end. So I am so in the first step I need to declare the persistent variable. So persistent variable uh, here it is. I am declaring it as count because the clock divider circuit should count the clock pulses. So clock divider by 5. Therefore, it should count 0, 1, 2, 3, 4. Again, that count value again it must move to 0, 1, 2, 3, 4, 5. Like that, it needs to repeat. So I am this persistent count is similar to a reg variable in Verilog. Okay, so this is the way we need to declare this persistent variable. So initially the count value must be 0. So we need to initialize the count value if is count of if is empty, if count value is empty, what I need to do? So when when the board is FPGA board or SoC board is initialized, this count value must be initially um, 0. Therefore, I need to use this. If is empty count, so count must be equal to 0. And this is the way we need to initialize a persistent variable. And next, I am typing the core program. So if we need to count, if count is equal to 4, so it will count in the sequence 0, 1, 2, 3, 4. When count reaches 4, what the program needs to do again, it needs to count, needs to go back to 0, right? Count needs to move to 0 again. This process needs to be repeated 0, 1, 2, 3, 4 again 0, 1, 2, 3, 4. This process repeats. So whenever count is equal to 4, I need to enable the clocks. That is clock out must be 1, otherwise clock out needs to be 0. So this a clock divider, this is how a clock divider will works. So I will use else statement, and then I will if what happens if count is equal to 0, 1, 2, 3. So in these cases, no need to worry about count value. So count value needs to be incremented by 1 step by step. Count is equal to count plus 1. For example, if count is equal to 0, so then it needs to be incremented by 1. So count is equal to count plus 1. Next, what about the clock out? For other cases, clock out must be equal to 0. So I will use n. So this is the structure of my program, structure of the clock divider program. So I will save it in any folder. So I am saving it to the extension clock divider, same extension clock divider. So it will be saved with the name clock divider. So I am going to use so this is a function, and then I need to program test bench for this. So I will create one test bench program. So I am initializing the and close all. So I am using a for loop to test this. For I is equal to for I equal to 0 is to 1 is to 99. So it needs to be repeated for 100 times. So I will use and how what program I need to call this function. So how I will call the function. So I will use clock out as the clock out as is the output variable. So you can use any variable name here. So I will call the function. Function name is clock divider. There is no input arguments, so I will program like this. So this is the structure of a testament program. If required, you can plot this clock out also. Clock. So I can use plot clock out. Right. If you execute this program, so I will save it first. So I will save this test bench program with a file name test bench. Okay. If you execute this program, what happens? Sorry, this mistake was defined. So sorry. A for loop should starts with uh, that array index must start with one. So one, I need to increment it by one. It needs to count till 100. Sorry. Okay, I will plot this graph. I will execute the program. So if I execute, it should show a plot like this. So if you check the waveforms, so for first four values it will be zero. Again it will go to one. Again remaining four value next four values zero. For next value it will go to one. Like that, it must repeat. So this is the output in MATLAB. So this is a clock divider circuit. Clock divided by 5 circuit. For first four values output will be zero, and next fifth value it must be one. Okay, I will convert this code to HDL code using MATLAB HDL Coder. So for that, in command window, you can type HDL Coder. So it will take away, ask for a file name. So I am creating the file, giving a file, project name as conversion, right? So I will click OK. Okay, so we have works. We have window gets open like this. This first in the first tab we need to include our MATLAB function. Function in the sense is our clock divider is the function. I will add it there. So in the second file you need to add MATLAB test bench. So I will add the test bench here. Test bench is nothing but the file name is test bench. Okay. So then after adding this, you can click workflow advice. It will open your HDL codes. So here you can check it's MATLAB to HDL. Okay, so you can execute one by one. So I will first convert fixed point conversion. So I will run the program. It will convert our MATLAB code to fixed point code converter codes. So it will display the output also at each stages. It will, must display the same output. So it's now this is verified. I will close it again. I will once it is finished, I can move to next step. Okay, fixed point conversion is successful. Next, I will give HDL conversion. So, which language you do record? You can click either VHDL or Verilog. I am choosing it as Verilog. You can convert to system Verilog also. So I require only Verilog code. I'm selecting Verilog. So please enable this generate HDL. Then I will again I run it. So or right click and click run this task. So if you click that, that HDL code will be generated. Yes, HDL code generation is successful. If you look at here, begin Verilog code generation working on clock divider underscore fix point. So one file will be generated like clock divider underscore fix point dot v. So that's the Verilog converted code, right? So thus we can see able to see our Verilog code there. You can able to see the program. So this is a program for clock divider. So it's a very long program. So I need to check whether this clock divider program is correct or not. For that I will copy this code, Verilog code from MATLAB, and then I will paste it on Vivado. So I am using Vivado here to check whether the program is logically correct or not. So I will create a project now. So I will create a project. Next, so I will give a project name. So I am creating the project of for clock divider, clock divider project. Okay, next, sortil project. Next, I you can click. You can if record. You can create file. So I need only one file. So you can check that file name for that. Here that in this the file that Verilog file name is clock divider underscore fix point. So I will use the same name here. So I will use the same name here. I will copy it. I will copy it and paste it there. So the same file name. Then I will give OK. So okay, I have created one Verilog file. Then I will give next. So add constraints that is not required. Next. So if required, you can choose any one board, right? So here I am using Vertex board. uh, any one board you can use. I will use Vertex board, or I will use Vertex board. Okay, so next, finish. Okay, so one project will be created. In this, there is will be one file name known as clock divider. So I will open that program. So it will be blank. So I need to copy and paste my MATLAB code here. So that is not Verilog code. That is MATLAB converted Verilog code. I need to copy it and I will paste it here. Okay, I will paste that program. So now I need to check whether it is perfectly working or not. So whether that clock divider is working or not. Okay, this is the program for, okay, so I will save it. So this is at top level, and simulation also I need to make it as top level. No need to worry, it's already in top level. So then I will run simulation. Okay, if I click run simulation, Mhm. So these variables and all not required. I will remove it. I need only the top level. So if you check the program there, um, if you check the sources, if you check the top level program, so clock reset, clock enable, CE out, clock out, these are the top level. So output will be from clock out, input will be clock, right? Other inputs are also there. Reset is one of the input, clock enable is one of the input. Outputs are C out and clock out. If required, you can use that also. So I will take to mm, the simulation part. So in the simulation, the internal variables are not required. So for easy understanding, the internal variables are not required. I will select only, I will keep clock reset, clock enable, C out and clock out. So other variables I will delete. Okay, these are essential. Actual output, clock divided output will be obtained from clock out variable. So clock input will be provided to clock input, so that we can verify. So how we can verify? I will create a clock. I will first click post clock and I will create a clock, simulate a clock. So I will give ones and zeros. So I will give with a period of 100 nanoseconds. Okay, I will give it as okay. Then initially I will make this reset as one, right. Clock enable is also, I will make it as one. Force constant, I will make it as one. And see out, these two are output, no need to set, right. I will execute it for 100 nanoseconds. Okay, so the but the reset value is, I can able to see it will be zero only. So but reset value is one, so the circuit won't work. So for it to start working, I need to make it as zero. So I will force the value to zero. Again, I will execute the program. Minimize, zoom out. Okay, so this is the output of, so the first line represents the input and the last line represents the output. Clock out is the output. Okay, we can check it whether it is working as clock divided by 5. I will pass the simulation process so we can check it. So I will zoom a little bit. Okay, so I will check the number of clock inputs. So here, first triggering occurs, first triggering occurs, second triggering, third, four, five. For 5 triggers, uh, the clock out is triggering once. Hence, it is working as a clock divider by 5. Thank you.